All right, welcome to the week 14 lesson of the ACT Math Prep course. We're going to talk about coordinate geometry today. So basically, any geometry that's on the X and Y plane. All right, coordinate geometry, right? We're talking about X and Y plane. Coordinates, right? So the first thing we want to talk about is the slope of a line. Okay, a lot of the times we talk about slope as rise over run. Rise of a line over the run of a line. So if I had a line that did this, I would say, okay, this distance here is my rise, this distance here is my run. When I do the rise divided by the run, I get what's called the slope. Okay, so first of all, when you see a line going up like this, from left to right, we're going to call that positive slope. Okay. When you see a line going down from left to right, we're going to say that that is negative slope. If it's flat, we say it has slope of 0. And if it's vertical, we say it has slope that is undefined. And that really just comes from this rise over run. If you have a positive rise over a positive run, you get a positive. Or if you come the other direction, a negative rise over a negative run, that's still a negative over a negative, that's still going to be positive. Here, if we think about it as a negative rise over a positive run, that's a negative over a positive, that gives me a negative. If I do a positive rise and a negative run, that gives me a positive over a negative, that's still negative. Right here, 0 rise and some number of run, 0 divided by a number of 0. And then over here, it says undefined. It's kind of hard to read, I know it's behind my face. But there's some number of rise divided by no run. So some number over 0, that's undefined. So that's where those terminologies come from. So remember, in a linear function, right, we write, one of our most common forms is this slope-intercept form. It's y equals mx plus b. Well, this number right in front of that x, that m, is the slope number. So when you write a linear function and you have y solved for, right, it's y by itself, you look over on the other side, whatever number is in front of the x, we call that a coefficient. That number in front of the x is our slope. Okay, so just remember m is the slope if we're looking at an actual equation for a linear function. All right, now there is a formula for slope. Okay, so this is the slope formula. So let's say if you're given 2 points, we'll call them x1, y1, and x2, y2. So just 2 coordinates, right? The first point and the second point. It doesn't matter which one is which, but the slope formula will be the difference in the y numbers. So y2 minus y1 divided by x2 minus x1. That is going to be the formula for the slope. Okay? So if you're given 2 points, you just use this formula here to find the slope between those 2 points. So this could be anything. I mean, you're talking about the radius of a circle, right? And you've got the center point here, and you've got this point here. Well, to find the slope between those two, you just do this formula, right? There's lots of different situations when you're going to use this formula. All right, so let's look at an example. Let's say we're given 2 points, -3, 0, and -2, -6. We want to know the slope between those 2 points. Okay, so what I can do is just plug it into the formula. It's y2 minus y1 over x2 minus x1. Now think about what this is. y2 minus y1, that's the difference in the heights, the y values. That is the rise. So that still is the rise. And the difference in the x values, that's the run. So it's still rise over run, right? We still want to think about it that way. All right, so let's call this x2 and y2, the second x and y. And we'll call this the first one, x1, y1. Now, it doesn't matter which one you call the first point and the second point, but you do have to make sure that you're consistent, okay? So y2, which is -6, minus y1, which is 0. divided by x2, which is -2, minus a -3. Now notice, since there's a minus sign in the formula, I have to put a minus sign. But then that x1 is negative, so I need to put a -3 there. There's going to be a double signs. So I'm going to have to change that to a plus. Okay, those two negatives make a plus. So I have -6 minus 0, that's just -6, divided by -2 plus 3. -2 plus 3 is +1. So we get a simplified fraction there, -6/1, which is really just -6. So the slope of this line is -6. Okay. Now remember, sometimes we like to think about it as rise over run if I want to graph it, right? So sometimes it's beneficial to think about it as -6/1. That will help me plot points if I'm actually plotting it. But remember, the simplified version is the one we would answer on a question like, what is the slope? But sometimes we want to think about it as a fraction, and all whole numbers are fractions with divided by 1 added on. Okay, now let me think about this a different way, right? We were given 2 points and we used the slope formula. Well, what if I had a picture? What if I knew that this was -3, 0, and that our other point was -2, -6? Well, I could use rise over run at this point, right? If I'm given a graph, if you have a graph, just use rise over run, just count. Just count. So the rise here is negative. Think about it like a vertical number line, right? Positive is up and negative is down. On a horizontal number line, positive is right, negative is left, just like the way we plot points. So the rise here is a negative what? Well, how far did I go down? Well, I was at 0 and now I went down to -6. So that's down 6. So I'm going to say the rise was -6 divided by the run. How far did I go over? Well, I just went over 1, right? Because I was at -3 and now I'm at -2. So there's my -6/1, which simplifies to be -6. So this is another great way to do this. If you have a graph, just use rise over run. Just count over and up, okay? Just remember, I could have started at this second point and counted up, which would have been a positive rise. So that would have been +6. But then when my run was -1, I would have still had a positive over a negative, which still gives me a -6. So you can think about it either way, but you'll still get -6 is your slope. Okay? All right. So it is possible that in that slope formula, there's 5 unknown things here. There's a m, there's an x, and there's an x, and there's a y, and a y. That's 5 total things. It's possible they could give you any 4 of those and expect you to find the 5th. So they could say the slope is 2, and that the coordinate is 1, 3, and 2y, where they don't give you one of the y's. You can't see that, sorry. Okay, it's possible that they give you this, where they leave one of the y's unknown. Okay, well, you would just use the formula. So m we know is 2, so I actually want to replace it with a 2. y2 we don't know, that's the y value here. Okay, y2 minus y1, y1 is 3, divided by x2, which is 2 minus 1. So then we could solve for y here. Okay, they could say, what is the y value of this second point? Well, you could figure it out. 2 is equal to y minus 3 over 1. Y minus 3 over 1 is just y minus 3, because anything over 1 is just itself. Then you would add 3 to both sides, and you would get that y would have to be 5. So you could solve for an x or a y in this case as well. It's a little more harder of a problem. It's not just directly using the formula, but it's definitely something that's doable. So be aware that if you're still talking about slope, you still use the slope formula. No matter what they give you and what they don't give you, just use the slope formula. Okay, all right, so let's talk about some special things here, some parallel lines. So if we have parallel lines, what does that mean? Okay, well, if they're parallel, they have the same slope. Right, I mean, just think about when we're graphing something. If something starts here and it goes up 3 over 1, that means that's its direction. Look over here. it would have to go up 3 over 1. It would have to be the same slope to be able to not ever cross. If things don't have the same slope, they're eventually going to intersect. So if they have the same slope, then they're parallel lines. So remember, m is your slope in this formula. So if I had something that said y equals 3x plus 1, and I knew that y equals something x minus 10 was parallel, I would know that this would have to be a 3. That slope would have to be the same. Okay, so if I said a line is parallel to another line and this one has slope of 7, you would go, oh, well then this other one has slope 7, right? You have to use that information wisely. Okay, perpendicular is a little different. Okay, perpendicular lines, right? They look like this, where they intersect at 90-degree angles. These have what we call negative reciprocal slope. And that's a very mathy term. I know that gets a little crazy, but what it means is, let's say this slope here was 3. Okay, well 3 is just 3 over 1. So when I say reciprocal, I mean flip the fraction upside down. So instead of 3 over 1, we're going to say 1 over 3. And then what does the negative mean? Well, if this is positive, this has to be negative. So this slope would be negative 1/3 if they're perpendicular. Right, so an example would be negative 4/7 would be one line's slope. What would a line that's perpendicular be? Well, it would be positive 7/4. Those are perpendicular slopes. So you can look at something and be given the slope, and then you can find the slope of something else because you know it's perpendicular. You just do the negative reciprocal. Okay? All right, so let's look at some examples of that. What if the slope was negative 7/3? What would the slope of a parallel line be? Right, parallel line should be negative 7/3. It's the same. What about perpendicular? Well, that's 3/7. Okay, negative reciprocal. Another example, what if the slope was 2? Okay, the parallel slope would be 2. What would the perpendicular slope be? Now this one you have to think about it. You have to think about it as a fraction because we're going to flip the fraction upside down. So you have to think about 2 as 2 divided by 1. So when you flip it, it's 1/2, and then of course negative reciprocal means you change the sign to a negative. Okay? So that is how you find any slope that is parallel or perpendicular to another slope, is you use that idea of either parallel is the same or perpendicular is negative reciprocal, or negative flip. Easy way. All right, so the next thing we're going to talk about is how to find the equation of a line. This is so common. This is on every ACT that you'll ever see, this kind of questions, okay? How to find the equation of a line. So they'll say something like, find the equation of the line that, and then they'll state some things like it goes through this point and this point, or it has this slope, or it's parallel to this line, but it goes through this point. They're going to give you some kind of qualifiers, but they're going to ask you to find the equation of a line. So remember, we have a couple forms here. Y equals mx plus b, that's one form of a line. Okay, we have the form ax plus by equals c, we call that standard form, and then of course ax plus by plus c equals 0, that's general form. They just move the c over. So we'll kind of want to review those a little bit. Remember, slope intercept is y is solved for. And then these standard form and general form, remember A has to be positive, the coefficient of the x term has to be positive, and A, B, and C have to be whole numbers, no fractions, no decimals, okay? I suppose they could ask you to find point slope form, which is this one. It's very possible that they could kind of ask you to find that one as well. So this is just a point on the line and the slope, okay? All right. So the first thing you want to do is find the slope. Okay, whatever it is, you got to find the slope first. So it's possible that you'll have to use the formula to calculate that. Okay, if you're given 2 points, you'll use that formula to find it. Alternately, a lot of the times they'll say, okay, your line that you're supposed to find the equation to is parallel to this line. So you'll have to steal the slope from another line. Now remember, when you're stealing the slope from another line, if they give it to you like this, 3x minus 6y equals 10, you don't get to say the slope is 3. because this is not in the form where m is, right? This is a and b and c. You've got to solve for y. So you would have to add 6y to both sides and get 6y plus 10 is equal to 3x, and then take away the 10. So there's a little bit of a process here, but you would get 6y equals 3x minus 10, then you would divide by 6. Now I don't actually care about this part because it's not the slope, but the slope is a half here. So make sure when you're doing this process that you put it in the right form, because if not, it's going to get you into some serious trouble quick. Okay, so you either use the formula, you steal it from another line, or it's given, right? Sometimes they just give it to you. They'll say, and the slope is 2. Okay, they give it to you. So in that case, you're not really finding it, you've got it in front of you, all right? Second thing you gotta do is make sure that you plug in to the formula, y equals mx plus b. You're gonna plug in what you know. So you're gonna have now a point. You're gonna have an x and y coordinate and the slope at this point, okay? They always give you one of the points, and then you have the slope, which you just found. You're gonna plug those 3 things in here. You're gonna plug in y, m, and x. What that's gonna allow you to do is solve for b, okay? So you're gonna find b, and that's your second goal. First you find the slope, then you find the b, okay? Now when you do that, what happens is you'll see, like if the point is 7, 4, and the slope is 2, you're gonna say the y value, 4, right? That's my y value from my x and y coordinate, equals m, so the slope, times x, which is 7, plus b. Then you just solve that little equation for b, right? You get 14 here, you take away 14 from both sides, you get negative 10 equals b, and there's your b, negative 10, okay? So that's what you're gonna do when that comes to b, is you're gonna find that b value by plugging in those values y, m, and x, okay? So that's kind of your second goal. Now, alternately, I'm going to put an or here. You could use this point slope formula, y minus y1 equals m times x minus x1. And that's where you plug in your y, your x, and your m. And then you basically don't have to solve for b. You just put this in y equals mx plus b form. This is another really good way to do it. In that same problem where we had 7, 4, and the slope was 2, what I would do is I would say, okay, y minus the y value. Well, that's my y value, 4, equals the slope times x minus the x value, which is 7. And when you solve this thing, you get y minus 4 equals 2x minus 14. See how I distributed there? You're going to add that 4 to both sides. You're going to get y equals 2x minus 10. See how the b is negative 10? You get it, the actual formula when you do it this way. You don't have to then go back and write it. So that's a really great way to do it too. Okay, it's kind of a preference at that point. All right, so those are your choices. You either use y equals mx plus b, or you use y minus y1 equals m times x minus x1. Then thirdly, you have to write it in the correct form. Okay, so do they want you to write it in slope-intercept form? Do they want you to write it in standard form or general form? Okay, these 3 or 4 forms over here, they're going to ask, all the answers are going to be in one of these forms, and you got to make sure you write it in that form. So that's another thing you want to make sure that you're able to do. Okay, so let's look at an example of this. All right, let's find the equation of a line that goes through the point 4, 5. So 4, 5 is on the line, and also it goes through the point 2, negative 1. So those 2 points are on the line. Okay, so let's look back at our 3-step process. First thing is you got to find the slope. We're going to have to use the formula here because we're given 2 points. Then you're going to plug it into one of those 2 formulas and then write it in the correct form. Okay, so let's say the correct form is y equals mx plus b. Okay, so I'm going to do it. First thing I'm going to do actually is find the slope. So I'm going to use the slope as y2 minus y1 over x2 minus x1. We've got y2 is negative 1 minus 5. Okay, y2 minus y1. Then x2 minus x1 is going to be 2 minus 4. So I get negative 1 minus 5 is negative 6. 2 minus 4 is negative 2. 2 negatives divided make a positive, and 6 divided by 2 is 3. So there we go. First thing I did was find the slope. Now I'm going to use y equals mx plus b to find the b. All right, so remember, plug in what you know. I can pick either of these points, 4, 5, or 2, -1. One of those has to be my x and y coordinates. It doesn't matter which one I choose. I'll pick 4, 5 just because they're both positive. It's kind of nice to work with positive numbers. So I'm going to say 5, that's the y value, equals m, the slope, which we found was 3, times the x value, which is 4, plus b. So I get that 5 is 12 plus b. When I take away 12 from both sides, I get -7 for b. Then I write it, okay? Y equals m3x plus b. Now notice when I write the equation, x and y stay as x and y. Those are variables. They have to be part of the equation. The two things that I'm writing as numbers are m and b, okay? That's the equation of the line that passes through those 2 points. All right, let's try it the other way. Let's use the other formula, okay? Maybe you prefer this way. All right, remember x and y, these are my coordinates, and then m is the slope of the line. So I'm going to say y minus the y value, which is 5, right? I'm using this coordinate up here again, equals the slope of 3 times x minus the x value, which is 4. Okay, I get y minus 5 equals, then when I distribute, I get 3x minus 12. All I have to do to write the equation is to move this number over, and I've got y solved for. Got y is equal to 3x minus 7, and that's my equation. Okay, should get the same answer either way. It doesn't matter which way you use, just whichever way you prefer. All right, let's try another one. Find the equation of the line that goes through 4, 5. Oh, sorry, that was the last one. Find the equation of the line that is perpendicular to 2x plus y equals 10 that goes through 0, 6. All right, I want to find the equation of the line that is perpendicular to this line 2x plus y equals 10 that goes through 0, 6. All right, so remember, first thing I gotta do is find the slope. Now, they don't give me 2 points, but they do tell me that the line I'm looking for is perpendicular to this line. So I'm gonna be able to use that information. Now, what's the slope of the line that they give me? It's not 2. 2 is not the slope. I have to get the 2x over. I have to solve for y in order to do this. Okay, I get y equals 10 minus 2x. Now I get the slope because y is solved for. M is the number in front of the x. So the slope is equal to -2. First goal accomplished. Okay, now I've got the slope and a point. Now that's what I need to do step 2. Okay, so I'm going to break this up. I'm going to do it both ways. I'm going to use y equals mx plus b. Okay, so what do I get? I get y. Remember, my y value is 6. So 6 equals the slope, -2 times x, which is 0, plus b. I get 6 equals 0 plus b. That's just b. So b is 6. So y equals -2x plus 6. Okay, use my m and my b to write that equation. Okay, now let's say they want it in standard form. Okay, remember that means I have to get my x's and y's on the same side. So I actually add this 2x over here, and I get 2x plus y equals 6. That's in standard form. My x coordinate, or my x coefficient is positive. The x's and y's are on the same side. No fractions, no decimals. We're good to go. All right, let's try y minus y1 equals m times x minus x1. Let's try that strategy. Y minus the y value, which is 6, equals the slope, -2, times x minus 0, the x value. Right, I'm using that coordinate 0, 6. 0 is x, 6 is y. Okay, I go ahead and distribute here. I get y minus 6 equals -2x plus 0, so I don't even write that. Then I got to get all my x's over here, so I add 2x to both sides. That gives me 2x plus y minus 6 equals 0. My other rule is I got to get this number over, so I add 6, and I get the same thing as I did on the other side, just a little different way. Okay, So I found my slope by stealing it from this perpendicular line that I knew of. I found the b, or I just wrote the equation, and then I write it in the right form. You got to make sure the end is that you write it in the right form. Now, shortcut here, okay? If you can recognize that 0, 6, let's graph 0, 6. 0, 6 is right here. That is my y-intercept. That is the b. If you're given a point that's 0 something, you're given the y-intercept. So the shortcut here is to realize you don't have to do all this work. You know that b is 6 because they give it to you. This is the y-intercept of 6 because x is 0. When x is 0, you're on the y-axis, which means it is a y-intercept. If you can recognize that shortcut, that's going to save you a lot of time. Okay, they do that for sure on the test once in a while. Well, they'll give you that without having to make you work for it. So keep an eye out for that. And basically this process just takes a little practice. You'll get comfortable with it and you'll get fast. And those are all the things we want to be able to do. We want to be able to do it accurately and quickly to sort of make sure we have lots of time for those other hard problems on the test. All right, so real quick, vertical and horizontal lines. Okay, what are the formulas for vertical and horizontal lines? Well, there's lots of ways to remember it. Let's just think about a horizontal line. What does it have in common? Remember, equations are just patterns. They show us the relationship between x's and y's. Well, this coordinate is 3, 2. This coordinate is 2, 2. This coordinate is 1/2, 2. This coordinate is -1, 2, -2, 2, and -4, 2. What do you notice about all the x and y's here? The y number is 2. That's the pattern. The y number is 2. So that's my equation. The y number is 2. Y equals 2 is an equation of a horizontal line passing through 2. Okay? Think about a vertical line. What do they have in common? Well, this is 4, 0. This is 4, 2. This is 4, -3. Well, the x number is 4. That's the only pattern. That's the only relationship between these x and y numbers. It looks random on the y's, but the x is very specific. So the x is equal to 4. That's the equation there. So here's how I remember it. When you're out on a boat and you look out on the ocean, you're looking at the horizon, right? Horizontal, horizon. Well, the horizon with y's in quotes. Y equals a number is a horizontal line. The other thing is think about the lowest point of a parabola is called the vertex. Vertical lines are x equals. Okay, kind of easy ways to remember that. Horizon, y is horizontal, vertex, vertical is x. You can also just plot a few points. You'll see really quickly, oh, the y values are all 2, or oh, all the x values are 4, or whatever. Okay, so just something good to put to memory there, those vertical and horizontal lines. Okay, so the next thing I want to talk about is midpoint. All right, midpoint is the middle of 2 points. So the middle of a line segment, if you will. Okay. So we got a graph here, we got a point here and a point here. This location, this little star, is the midpoint. It's the same distance from both sides. This is a really easy formula to remember if you just think about it as in terms of averages. Whatever this x is and this x is just the average, right? Whatever this y is, whatever this y is, this is just the average of those two y's. So how do you find the average of two x numbers? Well, you add them together and divide by 2. How do you find the average of two y numbers? You add them together and divide by 2. That's the formula. You take two coordinates, x and y, you add the x numbers, you divide by 2. You add the y numbers, you divide by 2, and then that is the x coordinate and that is the y coordinate. Really, really easy, okay? Now, there are some ways to make this a little bit harder, but we're going to start out with an easy example. So we'll just be given 2 points. So 3, 6, and 2, 4. I want to find the midpoint of those two. All right, well, I add the two x numbers, divide by 2. I add the two y numbers and divide by 2. So 5 divided by 2 is 2.5, or 5/2. And then 10 divided by 2 is 5. So that's the midpoint. Average of the x's, average of the y's. Okay? Now, what can happen is they can make this a little bit more difficult. okay? They could say, you know, AB is a line segment where C is the midpoint, okay? So you got A, C, B. What they can do is they can say, okay, this is at 3, 6, this is at 7, -2. What is the location here? They can ask you for the opposite. So what is the location here? All right, well, I know that the average 3 plus x, the average of this should equal 7, right? That's where I get this number 7 from, is the average of the 3 and the x. So there's my little miniature equation. 3 plus some number divided by 2 should be 7. Okay, that's totally doable. 3 plus what divided by 2? Well, I could go ahead and solve this like an equation by multiplying out the 2. That gives me 3 plus x equals 14. And I know that 11 is the only number that works there. 3 plus 11 makes 14. So this has to be 11. Then I do the same thing with the y values. I know that 6 plus y divided by 2 should equal -2. And I just do the same process. Okay, it ends up being -8, because I can think of 6 plus -8 is it's -10. 6 plus -10 is -4. When I divide that by 2, I get -2, and I've got my right answer. Okay, but just remember, anytime you're talking about midpoint, use the midpoint formula. Like add the 2 x's, divide by 2, add the 2 y's, divide by 2. Doesn't matter what they're asking for. You use the same idea every time. Just certain things are known and certain things are unknown, and you can solve for certain things. All right, so let's look at this line segment, okay? Let's say we have A, B, and C. And we know that B is the midpoint of AC, okay? So there's a lot of things we know here, okay? I know that AB and BC are equal. AB equals BC. I also know that AB is half of AC. I also know that BC is half of AC. I also know that 2 times AB is equal to AC. Oops. And I know that 2 times BC is equal to AC. Okay? All these things are expected for you to know. They could give you an expression here. This is x plus 15, and this is 3x minus 7. And you say, oh, they're equal. Set them equal, solve for x. Or they could say the whole thing is 10x minus 12, and they don't give you BC, but they just give you AB and this big one. Well, you should go, oh, well, x plus 15 times 2 is equal to the big one. So using any of these 5 things, you got to be able to write an equation from these, understanding how midpoint works. Midpoint cuts something in half. So the small half is equal to the other small half, or double the small is equal to the big, or half the big is equal to the small. All these relationships should be able to build a formula that you can solve for the variable. All right, these problems are very, very normal and easy to do if you just remember that I just got to set up an equation. What makes sense? Sometimes I write it in words. 2 times the small equals the big, right? Well, 2 times the small, right, in our picture, that's x plus 15, equals the big. There we go. I took words and converted it into an equation. Okay? So once you set up the equation, you solve it, and you answer the question. Remember, they could be asking what's the length of AB, or what's the length of BC, or what's the length of AC, or any of these questions. But you just make sure that you answer the question that they ask. Okay? All right, next topic is the distance formula. All right, so we've got 2 points, one here, one here. I want to know the distance between those 2 points. Okay, now remember, if it's a horizontal line and they ask you for distance, you just count. It's really, really easy. If it's a vertical line, same thing, you just count. Oh, it's 10 spaces over. Well, the distance is 10. But once it becomes diagonal, then you have to think about it in a different way. Okay, so basically, the idea is that this is just Pythagorean theorem in disguise. A squared plus B squared is equal to the distance squared. So what we do in the formula is we square root both sides, And we get that the distance is the square root of a squared plus b squared. Well, what is a squared plus b squared? How do you find the distance between 2 points? You subtract. You take this x minus this x, and you say, oh, like the distance between mile marker 10 and mile marker 15. You subtract 15 minus 10, you get 5. That's the distance. We're always subtracting when we want to know distance. So what it really comes down to is the difference, or the distance between the x numbers squared, plus the difference in the y numbers squared. That's really the distance formula. But really, it's just Pythagorean theorem in disguise. Okay, so you got to memorize that formula for sure. Now they can ask you to find the distance, or they could ask you to find one of the x coordinates. Okay, that's of course a little bit harder, but you got to be able to do it. You've got to know the distance and be able to find x2 right now. It's a little bit of work, but you got to be able to do that. Okay, now if they do that, you can use guess and check. That's a great time to use guess and check, and we'll go over some examples and see how that works. All right, I'm just going to write this formula up here. Difference in the x's squared plus the difference in the y's squared, all added and then square rooted. That's the distance. All right, so let's find the distance between 5, 0 and negative 5, 6. Okay, so this is my x1 and my y1. This is my x2 and my y2. So x2 minus x1. All right, negative 5 minus 5 squared plus y2 is 6 minus 0 squared, all of that square rooted. So the square root of negative 5 minus 5, that's negative 10. When I square that, I get 100. That's 6 squared, which is 36. So I get the square root of 136. Now they could have a decimal. They could have a square root of 136. Chances are they want you to reduce that. This is 2 times 78. 2 is a prime number. 78 is 2 times 39. 39 is 3 times 13. Those are both prime numbers. So you put your pairs together out front as a whole number. Anything left over, you multiply. So 3 times 13 goes under the radical. If it has a pair, it comes out front, out of the radical. If not, it stays under the radical. So 2 root 39 is the answer. Now remember, you could always check that with a calculator to show that it's the same thing. But really, you should be able to break that down. All right, let's find the distance between 10, 7 and negative 3, 7. Okay, so we have the square root of x2 minus x1 squared plus y2 minus y1 squared. All right, so x2, that's negative 3 minus 13, or excuse me, 10. Negative 3 minus 10, we square that, plus 7 minus 7 squared. We're going to square root that whole thing. So we get negative 13 squared plus 0 squared. So negative 13 squared is just 169, plus 0 is 169. We get 13. And this was a lot of work. What I should have realized, right, is that 10, 7 is here. Negative 3, 7 is here. They're on the same horizontal line. I should have just been able to count 13 spaces over. If you recognize that, if you see two y values the same, they're on the same horizontal. If the two x values are the same, they're on the same vertical. You can just count at that point. Of course, this way works, but sometimes we want to look for little shortcuts. All right, let's try this. The coordinates 3y and 7, negative 5 are on a line, and the distance between them is 5. Find the y value. Okay, well, we're not going to change anything that we do here. We're going to use the same distance formula. x2 minus x1 squared plus y2 minus y1 squared. Fill in what we know. We know that d is 5, so we plug it in there. All right, we've got x2 minus x1, that's 7 minus 3 squared, plus y2 is negative 5 minus y squared. Okay, now look, first of all, guess and check is a great option here, right? You could plug in a number for x or for y and see if it works or not. It's pretty quick and easy to do. But I'll go ahead and show you how to do this. 5 is equal to the root of 4 squared plus -5 minus y squared. Now this right here is not as easy. You don't get to just distribute the squared to both parts. You actually have to multiply that thing out. So we get the square root of 16 plus -5 minus y times -5 minus y. So I distribute there, I get 25 plus 5y plus 5y plus y squared plus 16, all rooted equals 5. See why guess and check is going to be a good strategy here? Might even be faster. Combine my like terms, I get, let's see, 41 plus 10y plus y squared. I'm going to square both sides. I get 25 is equal to 41 plus 10y plus y squared. This is going to be quadratic, so I'm going to subtract 25 from both sides. I get 16 plus 10y plus y squared equals 0. Now I could try to factor this. Two things that multiply to be 16 that add to be 10. Yes, this is going to be y plus 8 times y plus 2. And you're going to get that y is equal to 8. Sorry, -8. And y is equal to -2. I just want to remind you, when you get to here, you can use your graphing calculator, right? You want to graph the left side, which is 0, and you want to graph the right side, which is 16 plus 10y. Of course, we're going to use x because we don't have a y, plus y squared. And you graph them. We're going to look for the intersection. So I can see it right there, -2 and -8. I could look at the table and see that these are equal at -2 and they're equal at -8. Right? The y values are the same. That means they intersect, -2 and -8. I could do second, I could look at the graph and go second trace, number 5, the intersection, enter, enter, enter. There's my first one, -2. I could do second trace, number 5, enter, enter, and then move over here to this other one. When you do the enter, 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 it just picks the one that's closest. So I get close, hit enter, there's my -8. Okay? All right, just a reminder on how that works. Guess and check can be a very good strategy. All right, so moving on to another topic, transformations. So we're talking about geometric transformations, not like function transformations. So any change to a shape's location. And when we're talking about location and we're in coordinate geometry, we're talking about the location of the coordinates, okay? So first of all, let's talk about reflections. There's 4 types of reflections. So we can do across the x-axis, across the y-axis, across the line y equals x, and across the line y equals -x, okay? There's 4 different ways. So if I'm looking at just this, this triangle here, I'm gonna note A is down here. A prime would be down here, where A prime is the name of the shape after I transform it. I flip it over, it becomes prime just to show the pre and post, the before and the after. So that's a reflection across the x-axis, right? It's like a mirror image across the x-axis. It flips over like a pancake. So across the y-axis, well, here's our A. Well, I flip over here, and now here's my A prime. I've gone across the y-axis, okay? Across the line y equals x. Here's A. It's actually crazy, but it just flips over to here, where A prime stays in the same location, because this is the line y equals x. So it just flips over. Now over here, here's my line y equals x, so it flips over to here, where this is my A prime. Okay? Wherever the line of reflection is, you flip across it, there you go. Now, we talked about this is the change in location as far as coordinates goes, and we're talking about coordinate geometry. So what they're going to actually ask you on the test, usually, they could give you a picture and say which one is the reflection across, blah, 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 and that's good too. But the majority of the time they're actually going to ask you for locations of the coordinates. So we want to talk about the location of the coordinates. So here we go. If we go across the x-axis, any coordinate xy, okay, is going to move then to the coordinate x negative y. Okay? Any coordinate, whatever, just changes to negative y. Okay? So negative y. So we just changed the sign of the y value. Okay? Negative y. Looks like a G, doesn't it? Yeah. So negative y. That's what we're going to call this one. So as an example, let's look at the coordinate 3, negative 2. That is going to transform to the location 3, positive 2. All we do is we switch the y value's sign. Just make it a negative. Okay? What if we go across the y-axis? Now, if the x-axis we switch the y value, what do you think is going to happen here? Some coordinate xy is going to go to negative xy. Exactly. We do a negative on the x value. Whatever the x value is, we just switch the sign. So example, 3, negative 2 becomes negative 3, negative 2. We don't touch the y value. We just switch the x value. Okay, you got to remember it's backwards because it's when you flip across x, you change the y. When you flip across y, you change the x. All right, what if we go across the line y equals x? Okay, well, this one's interesting. The xy coordinate turns into a coordinate yx. Now, what did we actually do here? We just switched. We flipped the x and y around. So we switch the x and y. We just switch them. So that coordinate 3, negative 2 becomes negative 2, 3. We just change the location there. Okay? Now, what if we go across the line y equals negative x? It's sort of similar, but we add a little dimension to that. Okay? The xy coordinate goes to negative y, negative x. So not only do we switch x and y, but we also do negative x and negative y. So it's both. So this coordinate 3, negative 2 becomes positive 2, negative 3. Now think about that for a second. We switch the negative 2 and negative 3, and then we flip the sign. So it's positive 2 now instead, and it's negative 3. Okay? So that is how we do those transformations. All right, so let's look at an example here. Let's take the coordinate 7, 6. Okay? We want to go across the x-axis. We want to go across the y-axis. We want to go across y equals x, and we want to go across y equals negative x. All right, so across the x, we would switch the y. So 7, negative 6. Okay, we go back to 7, 6. What if we flipped it across the y instead? Well, we'd switch the x number. So it's negative 7, 6. Okay, boom, boom. What about y equals x? That's where we flip the y and the x value around. And then this one would be the same thing, but we make them negative. Okay? Now be aware, they could give you multiple. So they could say, flip across the line y equals x, then across the y-axis. Okay? So there's multiple transformations. So you do it like you normally would. You just do two separate things. So the coordinate 7, 6, when you flip across y equals x, becomes 6, 7. And then when you flip across the y-axis, it becomes negative 6, 7. So we switch the x number. So this would be the location. So this is like multiple transformations. Just be aware that they can have more than one. They want you to do it first and then do it again. Okay? So the next transformation we want to talk about is a translation. Translation is just a slide. When you slide something over, you go, stays the same shape, you just slide it over left, right, up, or down. So this is the easy one. We like this one, okay? It's either left, right, up, or down. Now you could do left and right and up and down at the same time, but you can't do left and right at the same time. Those kind of counterbalance each other out to where you wouldn't say, go left 5 and then right 5. Just stay where you are, right? Okay, so let's look at an example. This is pretty quick and easy. So let's say we translate right 5 and up 2. Now you got to know this notation. This is the only tricky thing. They will say the coordinate xy goes to the coordinate x plus 5, y plus 2. This notation means what these words say. Take any coordinate xy and you add 5 to the x coordinate. Well, when you add 5 to the x coordinate, you're moving it to the right 5 units. And when you add 2 to the y coordinate, you're shifting it up 2 units. So just be aware that they could give you just this and say 3, 2 after the translation ends up where? And you just got to remember, oh, I add 5 to the x and I add 2 to the y. Okay, so let's think about this point 7, 2. Okay, if I go right 5, that's going to add 5 to the x coordinate. So we do 7 plus 5 to get 12. And then I add 2 to the y coordinate. So plus 2. So really it's 7 plus 5, 2 plus 2, which ends up being right here. So this is the new location. Now I suppose they could ask you the backwards and say, some point was translated by this transformation. Where did it start? So let's say it ends up at -3, 0. Where did it start? Well, what point would be to the left 5 and down 2? Because that's how you would need to be ended up at that location by going right 5 up 2. So you would actually take away 5 at -8, and you would take away 2 to be at -2. This point is your starting point that ends up here. So you kind of have to think backwards on that, almost like do the opposite of what it says. If you know where you end, you can backtrack to where you started. All right. So moving on to the next transformation is rotation. All right, so there's two things. There's clockwise, and then there's counterclockwise. Okay, you got to understand the difference. Remember, clockwise travels in the way that a clock moves, counterclockwise goes in the opposite direction. So here's how it works. I'm just going to teach you how to rotate 90 degrees clockwise, and then I'm going to teach you how to rotate 90 degrees counterclockwise, and you can extend that to the other degree rotations. Okay, so easiest way to think about this is to look at this point right here, 4, 0. If I rotate clockwise 90 degrees, it is going to end up down here at the location 0, 0, -4. So what happened there? Those two numbers switched, and then we flipped the sign of the 4 to a negative. Okay? So the first thing we did is we flip the XY numbers. And then we switch the second number's sign. Okay? So what we did is we took this 4, 0 and we changed it to 0, 4. That's the first step right here. And then the second step was we switched the sign of the second number. Okay? So here's how I remember this. Right? A clock has a second hand. The seconds on a clock, right? So clockwise, you change the second number. You flip the sign of the second number. After you flip them, you switch the sign of the second number. On a clock, you have a second hand. That's how I remember that. Seconds on a clock. Okay, now look, if you rotate 180 degrees, all you do is you do this thing twice. You do it once, and you do it again. If you do it 3 times, you will have rotated 270 degrees. So you just do it 1, 2, 3 times. Okay, so let's look at an example. Let's start with -2, 4. Okay, this is a coordinate. I want to rotate this coordinate 90 degrees clockwise. Okay, then I want to rotate it 180 degrees clockwise. Then I want to rotate it 270 degrees clockwise. Okay, now remember, to do it 180, you've got to know what it was when you rotated it 90. You're kind of building off each other. So let's do it. Let's flip the signs. That makes it 4, -2, and then we switch the second one. So 4, +2. That's a 90 degree clockwise rotation. Let's do it again. Flip the numbers, change the second one. So make it 2, 4, and then instead make it 2, -4. See how we switch the numbers and then we flip the sign of the second one? Because remember, there's seconds on a clock. Clockwise, you flip the second one. We'll see how that changes when it's the other way. All right, let's do it one more time. Rotate 270. So flip the numbers. That makes it -4, 2. -4, 2, and you switch the second one. -4, -2. That's a 270-degree clockwise rotation. I mean, you can really look at this and think about it. -2, 4 is right here. When I rotate it 90 degrees, I'm over here. When I rotate it 180 degrees, I'm right here. 270, right here. Okay? So you can see how these coordinates work. This is 4, 2. This is 2, -4. And this is -4, -2. Right? -4, -2, 2, -4. Those points all make sense in this idea. So flip the numbers, switch the second sign when you're rotating 90 degrees clockwise. Seconds on a clock. Okay? Now, what if I want to rotate 90 degrees counterclockwise? So the opposite direction. So instead of rotating the way a clock moves, I want to rotate the opposite way. Okay? Well, here's my steps. You still flip the X and the Y, but guess what? You switch the first sign. The first number. Now, this is after you flip them. It's important. This is after the flip that you switch. If you switch before, it won't work. Okay? So same thing. If you want to go, 90 degrees versus 180, you just keep repeating it until you get to where you need to be. So let's look at an example. 3, -1. Let's go 90 degrees counterclockwise, 180 degrees counterclockwise, 270 degrees counterclockwise. Okay? Flip them, you get -1, 3, but then we switch the sign of the first one. So it's actually +1. So 1, 3. Do it again for 180 degrees. Flip them, you get 3, 1, and then you switch the first sign. So -3, 1. 270, you flip them, you get 1, -3, and then you switch the sign of the first one, -1, -3. Just think about this picture. 3, -1 is here. 90-degree rotation counterclockwise gets you to here. Another 90 degree gets you to here. And another 90 degrees gets you to here. And those are those 4 points, right? This is 3, -1. This is 1, 3. This is -3, 1, and this is -1, -3. Straightforward. Now think about this. Let's say I'm at this point 1, 3. I go around 270, right? 270 gets me to here. Couldn't I have just done a 90 degrees counterclockwise or clockwise? Yeah. So remember, 270 degrees counterclockwise is the same thing as doing 90 degrees clockwise. So if it asks you to do 270 counterclockwise, I would just go 90 degrees clockwise. Also, 270 degrees clockwise is the same thing as 90 degrees counterclockwise. So I would, again, just do 90. Now, 180 is the same either way. It's the same amount of work, so it doesn't matter. Sure, 180 counterclockwise is the same as 180 counterclockwise, but it doesn't benefit you to do it either way. Okay? So you can pick your favorite there. All right, last thing, dilations. Now, in all the other transformations we had, when we did reflections, the size of the shape stayed the same. When we did rotations, the size stayed the same. When we did translations, the size of the shape stayed the same. With dilation, the size actually changes. All right, and it's really easy to understand how this works. Basically, you have a shape like this. And then you've got coordinates, okay? This is 2, 2, this is 4, 0, and this is 0, 0. Dilation works in terms of a scale factor. So I can expand or contract with this scale factor, okay? Now, all I do is I multiply by the scale factor. So let's say the scale factor is 4. All I'll do is multiply every coordinate by 4, and that will give me my new location. All right, everything's going to be 4 times as big now. So 4 times 0 is 0. 4 times 0 is 0. 0, 0 doesn't actually change. But here, this becomes 8, 8. because I multiplied 2, 2 times 4. And this is going to be over here at 16, 0, because I multiplied 4 by 0 and 0 by 0, or by 4. So basically, you multiply by the scale factor. Sometimes you'll be asked to find the scale factor, and all you do is basically divide the big one by the little one to get 4. Like, what number did I multiply by, right? So remember, if your scale factor is bigger than 1, things were going to get bigger, right? Your shape will increase in size. If your scale factor is less than 1, your shape will get smaller, okay? Now remember, you don't actually have to have a picture here. You could just have 7, 2, and 10, 1, and -3, -3. Maybe this is a triangle. And you say you want to dilate by a scale factor of 1/3. So all you do is multiply all the coordinates by 1/3. You get 7/3, 2/3. This is going to be 10/3, 1/3. This is going to be -1, -1. Okay, that's basically all you got to know about dilations. It's an actual zoom in or zoom out. It increases or decreases the size, and it's basically just multiplying the coordinates by the scale factor. All right, that's all I got for you today. Appreciate you being here, and we will see you next week.